The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to SolidCAM UK's webinar on multi-blade machining. This is one of the advanced segments that's available within SolidCAM for the 5-axis operation. As you can see, it's one of the options down here. Later on, my colleague Les will be doing port machining, but today we're going to do a little bit on the multi-blade machining here. Now, I've used this file because this is a file that comes with SolidCAM, so anybody can have a go at this if they do have this capability in the later versions of SolidCAM. Now, as you can see here, there are a number of operations set up. And the first operation is, of course, to rough out the segment that you're going to work on. We'll be looking at these in more depth in a few moments. So, basically we've got one segment there. I'm going to rough that out. Then we're going to finish the faces here. First one, the second one. Then we will look at the fillet area between the hub and the blade. That's this little area in here, and you can see this transition between the blade and the surface has to be quite good, because in a thing like this, the turbulence can be generated by rough edges in the centre. So it just doing it right, make sure the air flows right. And again, you can see the fillet on this face. Then we actually have to machine out the hub to make sure that this face is correct. So those are our sequence of operations. Now I'm going to be going backwards and forwards between these and using them like a reference, shall we say. So the first one I've selected here is the roughing feature. Now we'll go through this just now. As you can see, this is identical, although rotated from the first one. So this is the ones that we've already done earlier, and this is the ones that we're going to be, the area that we're going to be working on now. So I'll switch that one off. So these files are actually quite a good way for helping you to understand what's happening, because these are already made up. You can go in and you can check to see that what's been set where, and get an understanding of what's happening. So let's look at this more closely. We open up our multi-blade in a machining operation, and we have rough, blade finishing, hub finishing and fillet finishing are the options that are available here. We're going to be using the roughing in this particular operation. As with most 5-axis, your coordinate system here will be coordinate system 1. The geometry that we're going to pick here depends on which option that we choose. So we've got offset from hub, offset from shroud, and offset between hub and shroud. So each of these three options, if I choose offset from hub, you'll see that we only have the blades and the hub. If I choose offset from shroud, again we've got all three faces, and offset between hub and shroud. We can apply stock to be left on these sections, and any start offset that we wish to choose there. Our tool in this case, we'll have a look at the tool, is a 12mm taper mill, and you can see the settings that are set up there. And the tool data, it's using silly feeds and speeds, so or very safe feeds and speeds, shall we say. But that's the tool we'll be using for all the operations on this. Levels, basically it's the clearance type, and as you can see we can either use sphere or a cylinder. Now depending on the type of machine that you're using, it may be that one's preferable to the other. There's safety distance here, as normal. You can set this up to give yourself more feed in or feed out before it retracts or plunges at high speed. Toolpath parameters here is our surface quality. We've got our cut tolerance as always here, where we can change this either by entering a value, or we can use the slider, which, as you'll see from the graphic on the left there, changes the closeness of the curve to the theoretical perfect. And again, we can change the flow line details here to smooth out or roughen it as we choose. Our tool axis control, in this case we've got a preferred lead angle and a maximum lead angle, and it's been set here for a side tilt of 30 degrees. Our link is basically left on automatic here, but if we change this, it's much like the older ones. You've got a number of selections where you can choose what you want to do with it, so we'll just leave it on automatic for today. Gouge check in this case is not on. Roughing and more, we're just leaving this at automatic. As it calculates, it looks at the stock from beforehand, and that's what this file name is here. We're only working with one segment here, but this allows you to set up how many segments you wish to machine on the part. So basically, if I save and calculate this, it takes a few minutes, and then we'll move on and do one of the finishing operations. But to make things easier and to understand, we'll move backwards and forwards between the ones that have already been done and check to see that we're following the same path as the already defined operations. As you can see, and then we're there, and we'll simulate this so that we can see what's happening. Now on this simulation, once it creates the model, you'll see that the already defined operations have already cut in this. I'll take a second or two to draw the stock. There we go, and we'll put it into solid so we can see it better. So that's what we're looking to achieve with the operations that we've set here. Now I'll let this run at full speed, and as you can see, the tool is gently stepping over as per the settings there, and it will step down to give us the clearance between these blades. It takes a minute or so to run this. We will allow it to finish so you can see how it handles it as it goes down. too far to go now. That's about halfway down. It's taking a wee bit longer than I expected here because there's a lot of calculations going on in here, and the simulation is trying to be as accurate as possible. No, we're not bad. Another 2 passes or 3 passes. So we'll stop that at that point, and let's go back and look at the very first one and see the differences there, and see actually, there we go, it's the same. So our next operation is the operation on the blade face or blade finishing. So here, if I create a new operation down here, and we'll choose blade finishing. Now let's have a look first at the geometry that we need to select here. So on this we had faces 3, offset from hub. Choose our tool. And toolpath parameters, what I'm going to do just now is choose face 3 for this, and the hub is face 1, and I believe we need offset between hub and shroud again, and that will be face 3. Tool selected, toolpath parameters, technology, contour, full, by maximum number, etc. These should be exactly the same as the one before. It's not extracted to contour. So let's just save this as it is, and we'll go back and look and see what we've missed. Right. Okay, so our geometry is 3, 1, 2, which is okay, there's no stop on it. Offset between hub and shroud. Toolpath, we have full, trim, trailing edge. One way, start from trailing edge, and climb. Tool axis control as it was before. Gouge check, roughing, they're all the same as they are in the other one. So we'll exit that, and let's go down here and have a look and see what we've done wrong. One way, start from trailing edge. Climb. It's raising an exception. There's something that I've not picked in here. Okay. Let's go back and have a look and see what the operation is here. Technology, full, trim, trailing edge. And we start from trailing edge. Automatic. Sorting, one way, start from trailing edge, and automatic. And it's raised an exception again. As you can see, these are the same settings in this. I'm not sure what's happened here, but as you can see, it's working on this one. So we'll go with this, and let's simulate this and see how this part of the path is working. You'll see in the first one that we've got this same shape as we machined there, and we'll go on, and now you can see that it's going to take both sides of the face and it's going to work its way down. So we're actually opening up the back side of the face as well. So remember, this is the finishing path on the blade surfaces. Okay, so that is it. We've finished that part of it. Now the next one here is using exactly the same style, but we're going to work on a different part. Let's just calculate it quickly, and we'll again put it into solid mode, and as you can see, we've finished down that edge there, and now we'll finish this edge. So using the rotational option, you can program for one part and then do select the number of rotations, and it will do the full number of pins. So there we go, there's our first and second blade, which is all we need, to be honest with you, finished. The next operation is to finish the fillet on both of these. As you can see, there's one for each operation there again. And what we're doing now is we're using the tool to clean up this area between the shroud and the fillet. The shroud and the blade itself, to fillet round about. Again, we choose our geometry and fillet finishing in here. Toolpath parameters as they were before. And we'll simulate this and see what it does. And you can see now that it's concentrating on the area at the base of the blade. And maybe from that angle you can see how the tool's moving to compensate. And that's that bottom section of that blade finished. The next one is just the finishing operation on the smaller of the fins, shall we say. And we'll just let that run. And you can see it's doing the same in here. So basically what we've done, to summarise, is we've roughed out between two fins, we finished the left hand fin, we finished the fillet round about the bottom, and now we're finishing the fillet on the middle fin. Right, okay. So last operation is to finish the hub, the area between the two. And as you can see, that has been selected here. So we'll simulate this. And we'll see how this works on. It's in the filleted area just now and works its way out into the areas that haven't been touched. And as you can see, the tool's moving to stay between the blades. It's being done automatically here. The calculation optimised to keep the tool clear of either of the opposing fins. And that's the operation set to form the fins on this part. If anybody has any questions, if you'd like to put them up now, we'll do our best to answer them. That's it. As I say, this file is available if you have 5-axis capability and the port machining is active on 2014, then you should be able to load this file and play with it. So I want to thank everybody, no questions, thank everybody for coming in, and I look forward to speaking to you again on some other subject later on in the year. Thanks very much for your time, and we'll see you again.